All right, week 4. We're getting through this, guys. We're going to make it. So this week we are going to be covering some spectroscopic techniques that are important for the field of bioinorganic chemistry as well as inorganic chemistry in general. So the readings are still from chapter 21 of the chapter, which is in the week 3 folder. We're not going to cover all the material in this section, but you can read more about some of the other techniques if you'd like. We're going to focus on 3 experimental techniques, 4 really, but 2 of them are X-ray. So EPR spectroscopy, which is NMR of unpaired electrons. X-ray techniques, including X-ray absorption, so it's like UV vis, but with X-rays. X-ray diffraction, which all of you know is my favorite experimental technique. And finally, Moss-Bauer spectroscopy, which is really specific only to iron. So we're going to learn about these 4 techniques, and you can read about them in the textbook. The homework is here. I have not written the keys for these homeworks yet. It's currently Friday afternoon on April 17th. But here are the homeworks, and I think they're going to be good. This first homework has you looking at an Excel spreadsheet, which I will put up on Sakai soon, just to sort of get an understanding for data presentation in EPR. And actually, let me step back and say, for these experimental techniques, I'm not really focusing on how the instrument works. I'm giving a little bit of that detail, but I'm more interested in you understanding how to know what kind of data you can get and what it's useful for. So this question is about EPR. This one is about X-ray diffraction. So I want you to go to a recent journal article and take a look at some of the metrics that I describe in the video. I will warn you, this X-ray video is longer than normal. It's about 40 minutes long, but I had a lot to say, and I also had a good PowerPoint already written, so I wanted to go through that. If you want me to evaluate your work on this, it's not required, but if you'd like me to, send me the screenshots that I ask you to take, and I'll take a look at it, but I will provide a key for one of my structures recently. Homework 3, oh, look at that, I just deleted it. Okay, homework 3 is looking at more of the X-ray data. It's going through the MMO protein, which is in a part of the chapter I'm not having you read. So don't read beyond what I ask you to here, pages 100 to 103. Try to understand how this data can be used to do the structure. And then the answer will be revealed in the X-ray structure here, so compare and contrast. Homework 4 has you looking at some Moss-Bauer. And then here are some skills. The answers to these skill questions are below, down here. Don't read them yet. But try to see if you can answer these questions before you take a look at the skills. And then finally, next week, the last week of school, we're going to explore the nitrogenase enzyme, which is my favorite enzyme. I'm sure that those page numbers are not correct. It's the last section of the book, so I'll update that before I post this on Sakai. But the nitrogenase enzyme is my favorite enzyme. I've been learning about it for longer than any of you have been alive, and it takes nitrogen and turns it into ammonia. It's an extremely powerful reaction that we are not very good at doing in the lab unless you like the Haber-Bosch process. Very thermally expensive reaction, whereas bacteria do this in the ground. Okay, so that's experimental techniques, and I'll see you throughout the week.